to have you. And we had a fantastic talk by Henry just now. And now we have Jernej calling in from Australia. Good evening, I guess. Good night, Jernej.
Hi everyone. Yes, I'm JK from Australia. Right now it's like 1 a.m. But it's a really good conference to be at, so I'm happy to be awake.
Yeah, we're happy to have you. Such a dedication to call in and join this conference. So thank you very much. And Jernej, you are a software architect in Brisbane, right? And just
Yes.
recently this week, you organized the Brisbane AI user group.
Yes, and it was really awesome. We actually had some cognitive services and speech APIs and showing people how we can do real-time transcription and then modify those transcription and put it back into cognitive services to improve future transcriptions, which is really, really insane.
That is pretty awesome. Well, that's fantastic. And we are so excited to have you here. And as always, everyone on the stream, if you have questions to Jernej, we're going to ask them just shortly after his talk. Please put them in the different chats we have here, Twitch and YouTube, or you can also put them in the Slack community. And if you haven't joined the Slack community, do so. It's a great place to connect with any other ML enthusiasts, such as me, myself, Jernej, and others. But I won't take any more of your time, Jernej. The floor is yours.
All right. So am I sharing?
Yes, you are.
All right. So hi, everyone. Welcome to Virtual ML.NET Community Conference. I hope you had a really good time so far. And I'm going to continue off with machine learning simplified for developers with ML.NET. Now, some of you have seen the workshop yesterdays. Some of the parts were covered already yesterday, but I'm going to give you a little bit of a different spin, a different perspective of what you might have seen yesterday. To begin first, let the clicker first. All right, clicker is now working. Let me reintroduce myself. I am Jernej Kavka, and you can just call me JK. I'm SSW Senior Software Architect. You can follow me at all these social media. My blog post, jkdev.me, connect me to LinkedIn. I'm co-organizer of Brisbane AI User Group. So if you're in Australia, you're welcome to join our virtual user group. By day, I'm doing a lot of .NET Core and EF Core, but at night, I really love to tinker with cognitive services and ML.NET, and recently also a little bit with VR. And this is kind of the setup for the current times. And when I'm looking at you, I'm actually looking at this little robot. Helps me connect with the audience a little bit better. And to make sure that I'm still healthy after these times, I am also experimenting with VR and exercise. And I must say, VR has come really long way. And this looks much tougher. It's really, really tough. I recommend it. And if anyone is interested about cognitive services, I have a Blazor client-side app where you can try out without writing any code. So if you're interested, ping me. All right, so I'm going to start the session with my story. So how did I got to ML.NET? Why did I even decide to go to ML.NET? What were my goals? And once I'm going to introduce that, I'm going to take a step backwards and I'm going to show you what is machine learning. And the reason for this is if I'm just going to show you, hey, these are the buttons you have to click, the magic is going to be lost. You'll be like, okay, these buttons do this, and you'll be like, oh, problem solved. What's the big deal? But showing you what machine learning is, once we click that last button, you'll be like, oh, wait, that's all we needed to do for all that stuff? And you'll be, I hope, more appreciative with what ML.NET Model Builder brings to the table. All right, so all of my projects kind of starts with a goal. And this goal kind of was quite simple. I had bank transaction descriptions And all I wanted is to get from this text to categories. That's all I wanted. And I, in fact, asked myself, okay, how hard is this? It's just two things, right? Well, I tried to solve this with Excel sheet because I wasn't able to get data from the bank. Then I started to write my custom C# code, first hard coded. Okay, that didn't work well. The bank transactions were constantly changing. Then I tried to write two different versions of rule engine in C#. It worked pretty good with regex and stuff like that. But then again, I had to change the rules, and sometimes that was really, really annoying. And the reason why I was so passionate to solve this problem, because I was doing manual classification of all my bank transactions manually every weekend. I really wanted to know where my money is coming to, so that I can save some money. So after a while, spending hundreds of hours trying to figure out how to solve this problem and manual inputs, I was like, hey, can I solve this problem with machine learning? It does kind of sound like a problem for machine learning, right? And how hard could it be to solve this problem with machine learning? I mean, how hard can it be? Well, one does not simply learn machine learning, is what I learned on a really hard way. And what I realized is, well, you start learning machine learning and they throw you some different phrases and you're like, okay, I need to learn all of this stuff. Now, I don't want to do the math stuff. I just want to learn what is machine learning, okay? So I want to be able to use the APIs that do the math for me. And I thought that's going to be easy, right? Wrong. Even when you exclude all of the math, you're starting to realize you have rabbit hole of a rabbit hole of a rabbit hole. Every single topic you cover is just another thing you have to spend hours learning and understanding. And after the weekend is over, you're like, I have done nothing yet. I have came no closer to solving my problem. And then I spent another weekend, and then I spent another weekend. And then I just came to realization that, well, time is infinite. It's not really infinite for me. So I decided that sometimes you just have to let go of dreams, and project failed. I gave up on machine learning for a couple of years. That is until Microsoft announced ML.NET. And I was like, yeah, right. Another machine learning framework. I've been there. And then I spotted one line that changed everything without any prior machine learning experience. That's the main reason why I went back to machine learning. And when I looked at ML.NET, there's a lot of things that I really liked. For first, it works offline. We have all the Azure stuff. It's really, really good, but I don't really want to pay for it until I know it works. And it's simple yet powerful, like all the .NET libraries should be. It's already been powered by a lot of Microsoft products. As far as I know, it powers Power BI, Visual Studio, Outlook, and lots of other stuff. I wasn't actually able to find the entire list, but that's what I remember from 2 years ago. It supports major machine learning models like TensorFlow, Onyx. So if you have already a data scientist that already done machine learning and already has everything ready, you can just say, hey, let me just consume this in a simpler API so I don't have to use all the other stuff. And one of the defining features, at least 2 years ago, was the awesome samples on GitHub. The reason for that is there was one sample called GitHub issue classification, and I did just some minor changes. And all of a sudden, I had my goal, at least a prototype of it, with just changing a couple of lines, and was like, that can't be true. I spent like 1 hour. That should be like a whole weekend thing, not 1 hour. And I wondered, and was like, yeah, it's working. I mean, data wasn't great, so it didn't work for all of the stuff, but I was like, what is this black magic? And hopefully now I hooked you a little bit on ML.NET, which I'm going to talk more about a little bit later, so that we look about what is machine learning and how does machine learning work in a really high level. I won't go too much into details, but just enough to give you a little bit of understanding why is it hard to learn. So what is machine learning like? The simplest way to explain it. Well, in classical programming, you have rules, which are usually the specification, and then you have data, which is usually from a form on a web page or something like that. And then we have the algorithms, which spits out an answer. So that is the classical programming. Well, with machine learning, it's a little bit different. The rules and answers are reversed. So into machine learning, we put all the data with all the answers, and then machine learning tries to learn the rules rather than us trying to figure out all the rules for all the answers. And this allows us to have a specific machine learning process, which we now call ML ops, where we can have training data, which then we put into the machine learning training algorithms, and then that outputs a model. A model is basically a binary zip file. It could be even an XML. It basically defines rules that the machine learning learned from the data. And then we deploy that model so that we can use it. So we can deploy it to desktop and mobile. We can deploy it to web. We can deploy it to IoT Edge. But this is not where the story ends. This is not the main strength of machine learning. This is just a portion of it. We then collect feedback. For instance, if we have desktop and mobile application or web application, the user might say, hey, this data was wrong, and this feedback comes back. Or we collect more data from IoT devices. So we learn more about their environments and where they operate. And we get that feedback back. And then we improve the data that we're getting back, and then we update the training data. And now we repeat the whole process. And this is how machine learning can continuously improve. It's getting back data, it's improving the training data, and then it can give us back a better model. And the good thing about this model, excuse me, the good thing about this model is that we can just replace the previous model, and now all of a sudden our applications are smarter with a newer artificial intelligence, if you will. So we don't have to redeploy the entire application. Okay, so we kind of have looked at how machine learning works from really bird's view eye, from really far away. Now let's have a look a little bit closer on the actual machine learning. So machine learning is a little bit hard to explain. So what I'm going to do is I'm going to split it up to a couple of types of machine learning. And I'm going to start with supervised learning. And sometimes it's called labeled data. So what this type of machine learning does is tries to learn from specific data that is labeled and tries to solve a problem, try to find rules based on what we're trying to learn. So for instance, the most simplest type of that is classification, which is further divided to binary classification. And a good example of that would be, is a tweet positive? So we're trying to do a sentiment analysis of true or false. Then another very popular classification is multi-class classification, where we're trying to classify an image into a label that we can then more easily use, or we can even generate a decision tree out of the inputs. Another one that is very popular in stock market is the regression. So here we can try to predict, for instance, house prices. On the other hand, we have unsupervised learning, and this is a bit harder part of machine learning. So what we're dealing here is we don't actually clean up the data in the same way as supervised learning, where we have nice inputs, and then we say, okay, for these inputs, that's the result. Here we have a little bit more chaotic data. Still, we use data science to clean up things. But one of the most popular subtype of that is clustering. So what this essentially allows you to do is cluster together similar data points. And that is most commonly used for product recommendation, where for one product, you look, okay, this user like this product. Let's see what other users that have similar likes also like. So we can then recommend a product based on that. Then a little bit more harder type would be dimension reduction, which is quite interesting because what you can do is you can have a complicated table and then you can simplify it so you can generate, for instance, some graphs, for instance. And this is just a couple of unsupervised learning. You have anomaly detection and lots of other types that are also very interesting. But for time, I'm not going to cover them. And the last branch is reinforced learning. So this one you might have heard, it's a continuous learning and it learns on the fly, and it's usually used with cars like Tesla, where you do autopiloting and it tries to learn as it goes. Now, the reasons why we don't have crashing cars physically is because Tesla is training the cars in virtual reality and then on test tracks. So we don't have to crash the cars, so they learn not to crash cars. But it's also frequently used in games as AI. All right, so there's a lot of stuff going on here. And this is by no means a full picture. This is a small fraction of machine learning. And each individual thing that I just mentioned, you could spend a month studying. So yeah, here you have like a year full of study worth of material. But I want to go a little bit deeper. So I want to say, okay, let's zoom in into multi-class classification. And if you decide to just learn that, what do I actually need to learn? Well, it turns out that is another thing where it opens up a lot of doors. And if you want to use multi-class classification, you have to learn what kind of trainers you can use on your data to get a model based on multi-class classification. And ML.NET already gives us some of the trainers. And the main difference between these trainers is based on the data you have, you might have pros and cons depending on which which trainer you use. For instance, one is great if your data is small. Another one would be great if you have a lot of different values, where another one is great if you have very few different values. So then you have to go through every single trainer and then figure out, okay, this trainer is good for this kind of data. This trainer is good for this kind of data. And you can read all of that in the Microsoft documentation. It's really, really good. But if you want to understand the pain of data science and machine learning, you can just follow graphs like that, where you start and then it's like, based on your data, you then dig to the right algorithms, probably, that will solve your problem. So you're starting to see that there's a lot of things to learn. And well, ML.NET solves all of the problems with learning the algorithms and stuff like that, you'll still need to learn a little bit of trainers, but we can go also without that, which we're going to cover a little bit later. And ML.NET supports everything you see here, except for that. So it currently does not support reinforced learning, unfortunately. I love reinforced learning, so I hope we'll have this sometimes in the future. All right, now that I scared you away a little bit with a lot of information, how do I actually start? Well, you start very simply with a scenario. What does that mean? Well, what do you want to achieve with machine learning? Is it maybe you want to figure out whether a tweet is positive or not? Then you go, for instance, for binary classification. Then you want to try to figure out the category of a bank transaction. Then you go multi-class classification. You want to do house prediction. You go regression. You go product recommendation. You go clustering. So you always start with scenario. So you limit the amount of things you need to learn. And there are a couple of caveats. Machine learning, before we move into ML.NET and demos, machine learning won't solve all of your problems magically. You will still have to understand your data. Even though ML.NET is going to solve a lot of problems for you, you still need to understand your data. If you cannot solve, say you look at the row and you hide the label, if you cannot tell what kind of label that could be, then there's a good chance that unless you have a good data scientist behind you, that the machine learning won't be able to accurately predict as well. Then usually what happens is when I'm doing machine learning, it's almost like I'm trying to guide machine learning toward the right solution. So I'm trying to modify the data a little bit, clean up the data, so machine learning has an easier time to learn how to predict the right solution. And start with something simple like classification. Classification, either binary or multi-classification, is one of the simpler ones that I was able to introduce people and they were able to get started. But you can also start with, say, image recognition and stuff like that if you have tools like Azure Custom Vision. All right, now the caveats are away. Let's look at the ML.NET and Model Builder. So, as I said, this can allow you to do machine learning without any prior knowledge. And when you're trying to get started with ML.NET, the first thing they ask you is, what is your scenario? And you can see there's a lot of scenario. We have sentiment analysis, product recommendation, object detection. There's a lot of things. And there's a lot more when you go to GitHub samples, and they're adding more and more scenarios almost every quarter or so. So yeah, that the number of scenarios is growing. And what ML.NET allows you to do is, if you look at the previous slides, it basically replaces the algorithm. So you don't have to think about how to implement different kind of algorithms, but you still have to decide for which kind of training you want to use for your data. Or do you? Well, this is where ML.NET Model Builder comes in. So ML.NET Model Builder is basically an extension to Visual Studio that works on top of ML.NET SDK. And the main purpose of it is that you don't have to decide what trainer you want to pick. It will pick the best trainer for you. So now we'll have almost no other decision other than what kind of scenario you want to pick to get started with machine learning. And also allows you to do quick prototyping, which I'm going to show you. So first, if you want to install the model builder for Visual Studio 2019 16.0 16.6, you will have to start your Visual Studio. You'll have to go Preview Features, and you'll have to enable here, enable ML.NET Model Builder. Now, if you don't see this option, on Monday, there's going to be a patch 16.61, which is going to fix this. But if you really want to get started today, and if you don't have that, and the workarounds are not working for you, Visual Studio 2019's 16.7 Preview 1 should work. So you can enable it through that one. All right, so let's go and try to do the demo. But before we do the demo, we need to see how we're going to have from where we're going to get the data and how the data is going to look like. So the data is actually my real bank transactions that was imported to a mobile app. I manually classified this for years, and then I exported that into CSV. So this is the CSV that we're going to work with. And I'm going to use this CSV almost raw. I've removed a couple of things, but basically I'm almost dealing with raw data from my bank. So that's why we're not going to see perfect data, but you'll see that even though I'm importing data directly from the source, we're going to be able to do a prototype. All right, so I am starting off here from the presentation showing you how to get started with model builder, because in my experience, sometimes the demo doesn't work and I have a backup for this. So first, we're going to select text classification for multi-class classification. Once we select that, we have the option to do only locally at the moment, but later we might be able to do it in Azure. So we select that. We then select the file we want to process, and we then select the first one over here is the column we want to predict, and then we select what kind of features we want for those columns. And then we do this training. And the interesting thing is when this training starts, we can see that it actually is dealing with a lot of different trainers. So it tries different trainers, and then it picks the one that has the best accuracy. And we can later use this to try to do our own prediction and see how it works. And here you can change the values and see if it predicts correctly. And if you're happy, you can go at the projects. And this is what you get is 2 new projects. One is the model. So here you have the zipped model, as well as the model input and model output, which is what you need for your applications to be able to interface to that ML.model, and the consume model, which has all the logic to be able to use machine learning. And lastly, you have the console app, which is just a test app, so that it shows you how to use ML.NET. But on top of that, it generated a model builder where you can then use to retrain your model with your data. So you don't have to go through model builder again to generate the code. All right. Now that I did this demo, just in case if the actual demo fails, let's do a live demo. May the demo gods be with me. So one thing that you have to know when you start, you will have to have a project already running. You won't find it under File, New Project, but you already have to have a project. It doesn't matter what project it is. Then you go Add and Machine Learning. So in case you're having problems finding that, that's where it is. And over here, we treat it with several scenarios. Down below, we have limited scenarios where you have more advanced scenarios that you can check out at GitHub. But we're going to be interested in text classification. We're just going to do locally. Now here you can also select to be SQL Server if you like to. I'm going to select my unfiltered data. I'm going to select categories as the column I want to predict. And I'm just going to train. So now what's happening here when I'm training is it's going to read the data and it's going to do a 50-50 split. One half is going to be training data and the other half is going to be testing data. And the number that you see here, 84%, is basically saying, based on the training data, when I compare it with testing data, it was okay, 84%. So this gives you a ballpark accuracy of your model. So this might not reflect the real life accuracy, but based on the data that you gave it to it. But you know what? We can improve this with just a little bit of data science. Now, if I go back to the data and look at the table that we have. Now, if you know just a little bit about multi-class classification, what you might know is date actually doesn't help us a lot with multi-class classification. It does help us a lot with regression, since any linear values helps them to have like a timestamp, but not really with multi-class classification, at least not dates. Day of the week, yes. Month, maybe. But yeah, most likely not. So what I'm going to do is I'm actually going to remove date. And previously we'd had about 84%. We had 84.21%. And if I retrain, now all of a sudden we have 1% more accuracy. And that's because we are removing data that is actually not relevant to our machine learning. So now we're doing data science. Isn't that great? Now you can say you're a data scientist. You removed one column because you understand it's not useful. Now, another thing that I'm going to do is I know that income is 0, so that's not useful. Currency is always the same, so that's not useful. The expense amount and in main currency is always the same, and currency and main currency is all the same. So I'll just remove all of that because that's all not needed. It's going to make your training faster, and you basically deal with less data to begin with. And it might even increase the accuracy because you have less noise. You have more useful data for the machine learning. So right now we see here we have slight decrease of accuracy, about 0.4%. But remember, we have a 50-50 split of data. So there's going to be always a bit of fluctuation of accuracy. But you know what? There is one little problem I have with this as well, with the data. Now, I understand my bank transactions, and I know, for instance, INZ Rewards is my credit card, where online shopping is a debit card. Now, what that means is if I decided all of a sudden that I want to buy everything with debit cards, the things that were trained against my credit card will suddenly not work well with debit card because it said, hey, this transaction is supposed to be with credit card. So I'm just going to say, no, it's not that category, or I'm going to have it as a lower probability to be that category because you're not paying with the same card as you did before. So that's not really useful, especially if you change your cards or if you switch from credit cards to PayPal or something like that. So I'm going to remove that. And what's going to happen is there's a good chance that our accuracy of the model is going to go down. But I'm happy with that because I don't want my machine learning model to predict what kind of category is based on what card I'm using. At that stage, it's just like guessing, okay, if it's using credit card, it's probably that. I don't really want that. So now I'm quite happy with the data I'm currently using. So I'm going to go to evaluate, and I'm going to play around a little bit with data. So if I'm going to go with predict, you can see it's 93% sure that it's leisure. And I'm going to go to my snippets, and I have here a couple of things. So this one should be home and utility. Let's go this one. This one should be coffee. Well, looks all right, right? Well, I would say yes, but I know there's a big problem with my data. What happens if, for instance, I have a really expensive coffee? It works. It's still sure that it's coffee. Okay. Now it's no longer coffee. Why? Well, all my big transactions are only transfer or reconciliation. So what happens is when the numbers are higher and higher, it now has a bias for transfer and reconciliation because it thinks, okay, it's a high number, so it's probably that. The description doesn't matter. But I know that the description matters more than the expense. I can just go for a really expensive coffee. It's still coffee. Well, the good thing is I actually learned that I don't need expense. I can actually remove it and my model would work perfectly fine. But if you find a similar problem like this, you can basically just try to balance the value. So you don't go too much into extremes. So for my example, I'm going to now also remove the description. Oh, not description, sorry, expense amount. So now we have a nice model where we have only one input and only one output. Nice, isn't it? And it's going to be almost exactly the same accuracy without expenses. So we essentially, from the beginning, we almost sacrificed no accuracy and we removed 7 columns. And this is what data science can help you out quite a bit. But there's also a little problem with that as well. So for instance, if I change the letter a little bit, all of a sudden, it's not the right one. It should be leisure, but it's now food and drinks. Now, this is a problem with my data set, and the model builder has a little bit of problem recognizing that this shouldn't be a category, should be free text. And if you have this problem, what you can do is you can just go to Excel, you quickly go to conditional formatting, you do highlight cells, I'll select this full one, and duplicate values. Now what you see here is there's a lot of duplication. And what that means is the model builder thinks that this description, because there's so many duplications, it's a categorical value. And then it hashes every single value rather than takes it as a string. Now you can solve this problem easily by just going data and then doing, sorry, where is it? Where is delete? Okay, it's a smaller resolution, so I need to find. Okay, so over here it should be delete duplications. Okay, it's over here. It's a smaller resolution, so the icon got reduced. So what you can do over here is just remove all the description, all of the columns except for description. you press OK, and now we have here that 1900 duplicates have been found and only 700 unique values were there. So now if I go to data and I'm going to just load this filtered one, and I'm going to select this one as that. When I train this, now what's going to happen? Takes a little bit to train. Now this is a bit cleaned up data. You'll see that the accuracy has reduced pretty significantly. And that's the reason is because now we have only unique values. If something exists only once, then that data might go into testing, and then it cannot be trained against. So you sacrifice that. So that's why I wouldn't recommend to do that and just call it a day. But what it means now is I can just say Spotify, and it's now 88% sure that that's it. But the problem is, when I retrain a couple of times, it might happen that the Spotify or some other training data might go on the testing side and may not be included in my model, and it won't work. So if you have this problem, what I'm actually going to do is I'm going to close Excel and I'm not going to save. There's an alternative to this. If you're happy with the previous unfiltered data as before, you can clear all the data, go to description, train it, and we're going to generate the code. Because what we can do is, after we trained and generated the code, we can actually change the type of the column the description is. So we'll do code, add project, save. So over here, as I mentioned earlier, we have the input, model input, which represents all of the data structures that we have as an input. Output, we have the prediction, which is the category, and the score. So for all of the categories, we get a numerical probability. And consume, which is the actual API that you can use in your application. And ML model zip is the actual zip file that we read and use in machine learning. Now I'll speed up a little bit because I might not have a time for a full demo. I'm just going to show you what we get when we run this. So here you can see we're getting prediction category leisure for Spotify. Now what I'm going to do is just to show you a little bit better view on this. I'm going to replace Microsoft output with my own. Did they change? Need to just think. And I run this. Okay, now we have a nicer view. So you can see here we have leisure, it's 95%. And we could see all the other products. And I'm going to use this example, which should be investment 93%. And you can see how sure it was for all the others. Now, if I change this by just removing, or let's say just changing one number, we're going to still have the same problem where it selects wrong one. To fix this, go to build a model builder. And this is the code that is actually used to train your machine learning. And over here in build training pipeline, we have description as categorical one hot shot encoding. So a couple of friends had the same problem. So that's why I'm showing to you. A lot of people have a lot of duplication in their data and they don't understand why this doesn't work. So what I'm doing here is I'm just changing this description column to be text, featureize text. And this solves so many problems because now it will split up the string of description and it will try to identify each individual string rather than as a whole, as a hash. And to retrain, what I'm going to do, model builder, and create model. And I'll just return it. So I'm going to just build this and exit it right away. So what we're literally doing is we are retraining our model with the same configuration we had before with model builder, but we have tweaked the machine learning pipeline to be more aligned with what we want. Now, one important thing to do before we rerun this, you need to rebuild it because it needs to copy a new set of ML model into bin. And I'm going to rerun this. And voila, investment. And now it's 99.7%. It's even more sure than before. And to prove you that this actually works with just a little modification, I'm going to remove almost everything. And it's still pretty sure it's an investment. So if you have this problem and you're happy with the data you have, you're just not happy with the decision that it's categorical instead of text, or you have this weird problem where you just change one thing and everything changed, you can still go ahead, generate, and just do a little tweaks. And yeah, with that, I hope you have learned how to get started with machine learning, how to get into ML.NET. You can see that you can easily get started by just importing CSV directly into your Visual Studio. You can tweak your columns to get better results, generate project with ML.NET Model Builder, tweak a little bit the generated code to just get the results you want. In case the model builder, you can just tweak it enough. And generally speaking, I'm also showing demo, but I ran out of time a little bit. If you happen to have a data set that is less than 100 rows, the model builder requires you to have more than 100. Now, I don't quite recommend this, but you can actually copy the data so many times that you get more than 100. But I've done some simple tests and it works. So if you have a data set less than 100, that's what you should do. And if you want to learn more, I actually have an interview going a little bit more in depth on the data science part for developers in my blog in this interview. You can ping me if you want to have the URL. And I have achieved my goal. I actually have this solution running and it's classifying my bank transactions, and I'm quite happy with the solution. My weekends are now free. I don't have to spend classifying my bank transactions. And with that, thank you.
Thank you very much, JK. That's amazing. Great presentation. You have some amazing feedback
Thank you.
here on the chat of this as well. We'll ask you some quick questions here before we go to the next talk here. But we have one question here from OSI that asks, given the example CSV about expenses, how would a model training look like if you like to predict future expenses?
Future expenses. I'm actually not quite sure. But what you would probably do is a mixture between regression and, yeah, you probably would, I would personally do per category or per transaction, and then count when they happen. and then regression could potentially tell me when the next transaction would happen. But yeah, it's a really good question. I would probably look at regression.
And I think there's also something like time series forecasting as well, right? That could help you with that.
Yes, that's correct.
Awesome. And last question here is, let's see, Prashant here has a question. Did the model builder select different models after JK changed the columns that were picked for training? Or did it select the same model every time, indicating that for a given kind of problem, the model selection is consistent?
So that's a really good question. Back in the beta, from 1.1 to all the way, I think, to 1.3, it actually did switch between average perceptron over, and what was the other one? There was another trainer, and it was switching between them, but it stabilized after 1.3. And I believe it's because if I'm not mistaken, ML.NET is now trying to guess which trainer would be the best ahead of time, and tries to do the parameters better tailored to that trainer, so you always get the same trainer for this particular case. But if you change data significantly, you would get a different trainer.
Okay, great answer. Thank you. Well, thank you very much for presenting here with us today, and the community, I think, really appreciate that. Thank you so much for the late evening, and I hope it wasn't too much of trouble. And yeah, coming up next here in just, I think, 8 minutes or 9 minutes is the Q&A session with a Microsoft data scientist. Justin will join us shortly, and he will answer all your questions. So definitely put them in the Slack community channel here, questions to data scientists, or start posting them in the chat for Twitch and YouTube. And we'll see you just shortly. Thank you.